Hello again, ladies and gentlemen. So for this lesson, I wanted to talk about how we can graph quickly. I've mentioned over the past few days that we want to avoid graphing as much as possible, but when we do need to graph, we want to speed that process up. I know graphing can be very frustrating. So what I like to talk about here is this idea of speed graphing, right? How can we get a line down as quickly as possible? What we used to do is take our equation, make a table of values, plot all those points, and then graph our line. That still works. And if you need to fall back to that method, by all means, you can do that. You will get the right answer. However, it's slow. And so let's see if we can speed things up a little bit. So here's our process that we're going to be going through. Over the past few lessons, I've talked about really what the m and the b value in our equation mean. So if we really understand those, we should be able to get a really good idea of what a graph looks like. So the first thing we're going to do is we're going to look at the b value, the y-intercept. That's going to be our starting point. That tells us where our line is going to begin. Then we're going to take a look at our slope. And using the slope, we should be able to find a second point on the graph. Well, once we have 2 points, that's a line. And so we'll take a ruler, draw our line, and we'll be done. So we should be able to graph these very, very quickly. Might take you 10 or 20 seconds at first, then we can get it down to maybe 8 seconds, and then 5, and we should be able to graph these very quickly with some practice. So let's try some of these. If you haven't already done so, take a minute, pause the video, and set up a graph similar to what I have here. Give yourself lots of room, -10 to +10. A larger graph is better. Don't try to cram it down into the bottom of a page. Make a graph, maybe use half a piece of graph paper so that you have room, okay? So once we've done that, let's look at our method here. We're going to do our first line, y equals 2x plus 3. I'll go slow to begin with, and then we'll start picking up the pace to see how fast we can actually do this. Y equals 2x plus 3. So the first thing I'm going to do is I'm going to look at my b value, which is 3 in this case. So I know I have a point right here at 3 on the y-axis. Then I look at my slope. Well, my slope is 2. So remember, slope is rise over run. So we could think of that as being 2 over 1. So a rise of 2, a run of 1. So what I can do to create a second point is from my y-intercept point, I can go up 2 and over 1. And there's a second point. And I can do that a few times following that pattern. Up 2 over 1. Up 2 over 1. Or I could go the other direction if I wanted, right? I could go down 2 and left 1. Right? Down 2 and left 1. And you can see all of these points end up being on a single line. So once I have that, I am able to take my ruler, draw my line, arrows to show that it goes forever in both directions, and I'm done. So I was able to get a very accurate line without a table of values. Let's try the next one. We can see here our y-intercept is -4, so my first point is going to be here on the y-axis at -4. My slope is 1/2, so rise of 1, a run of 2. So I'm going to go up 1 over 2, and there's my next point. Up 1 over 2, there's another point. I could go in the other direction. Down 1, left 2, like that. And again, very quickly, there's my line. This depends on your knowledge, and we need to know what the b value is, our y-intercept. We need to know what slope is, that idea of rise over run to get our patterns. But if we understand those two things, you can see how quickly we're graphing. Right, this third one in red, -3 over 5x plus 1. So my y-intercept is here at +1. Now be careful here because my slope is negative. So my rise is -3, which means I'm going to go down 3, and my run is 5. So I'm going to go down 3 and over 5. And there's my second point. Again, you can make more points if you want. You can go in the other direction, but as long as you have 2 points, that's enough. to get a nice straight line. And there we go. Just like that, our line has been drawn. Let's do a few more examples. What I would say for this one now, go ahead and pause the video, and can you graph these three in the same technique that we did before? I'll give you a second to pause the video and graph these three lines, please. Okay, so for the first one, y-intercept is -5. We have a slope of -4, so -4 over 1. I'm going to go down 4 over 1. There's my second point. Bring my ruler over. And there's my line. The slowest part of this is just setting up your axes the first time. But once you have your graph set up, the line itself can be done very quickly. For the second one, y-intercept of +2. Oh, get a blue here. Y-intercept of +2. My slope is -2 over 3, so I'm going to go down 2 over 3. There's my second point. There's my line. The slowest part for this for me is, because I'm doing this on a computer, is adjusting that ruler. For you, you have a ruler in your hands, you can get this done much faster. All right, last one here. Y equals 5x plus 1, so we have a y-intercept at 1. My slope is 5, so I'm going to go up 5 over 1. There's my second point. And there's my line. Okay, so much faster than a table of values. And hopefully this will take some of the frustration off of the graphing we've been doing, because moving forward, we're going to be graphing quite a bit. And so if we can just graph very quickly using these techniques, we can move on to the actual emphasis of what we're doing, and we'll see that next unit in chapter 4. Okay, 3 more examples here, and then we'll finish up. So graphing these lines, these ones look a little bit different. So for this first one, y equals -3x. What's the b value? Well, the b value would normally be here, so we can think of that as +0. So we're just dealing with a y-intercept of 0 in this case. It's passing through the origin. Other than that, it's the exact same thing. So we have a point here. Our slope is -3, so I'm going to go down 3 over 1. There's my second point. And there's my line. Now B and C look different. We have seen these before. If you recall, these are some of our special cases. These are horizontal and vertical lines. Let's look at B first. Y equals 6. Now another way I could write that is I could say, well, that's y equals 0x plus 6, right? So the 6 is our y-intercept, and our slope is 0. So a slope of 0 just means a perfectly horizontal line. There we go. And again, when we have the line y equals 6, we can see every point would have a y coordinate of 6. 2, 6, -4, 6, something 6. For our last one, x equals -3. This is our vertical line scenario. So if you recall, for a vertical line, whatever the x value is, we're just going to draw a vertical line at that point. So I'll just bring my ruler right over here to x equals -3 on this side. And there's my line. And no matter which point I choose on that line, it'll always have an x coordinate of -3. So there's a real quick rundown of how we can graph our lines much, much quicker as long as we know the significance of our m and our b values from the equation of a line. So let's go ahead and practice some of these guys. Page 143. Try to get those done as quickly as possible. You can, of course, use a table of values if you need to, but let's try to practice these new techniques and get our graphing down so that you should be able to get a line drawn inside of 3 seconds. As long as your graph is already set up, the line itself shouldn't take any more than a few seconds. As always, email me if you have questions. Good luck.